Hi, it's Karsten here, and I'd like to review weld procedure development with you. I suspect some of you will be in positions of being responsible for welding procedures, and I wanted to pass along my suggestions on how to make excellent documents to fulfill their function. Understand clearly, the function of the procedure is to provide instruction to the fitter, the welder, and the inspector for how to prepare the joint, set up and make the weld, and finally state the required weld requirements for inspection. The production requirements means future work that needs to be planned to be ready for production welding at some point in the future. Review engineering drawings to identify considerations influencing the welding procedures. Meet with the production team to decide how the various fabrication joints should be welded. Initial procedure development is to determine parameters when welding the PQR test plate. Follow these 4 steps in weld qualification assembly. Once the procedure is qualified with CWB or TSSA, then experiment on simulations of all the joints needed on the fabrication to determine best practice variables and then create those procedures. Review existing welder qualification records and, if needed, qualify an adequate quantity of welders to meet new production requirements. To ensure quality and productivity needs are met, production welding should be monitored to ensure procedure compliance. Okay, let's not be too serious. Here's the new all-position welder qualification. Moving right along. In having an efficient qualification system for ASME code welding, you will need to review existing procedure and performance qualifications and create new procedures or qualifications only when necessary. Your goal will be to get to the green OK square as quickly as possible. This summarizes the 3 items needed for ASME code welding compliance. The WPS is the instruction document telling the welder how to make each weld. The PQR is a record of proof procedures have been qualified to ensure mechanical properties equal to the base metal, with the test results listed on that document. Performance qualifications means the welder has been tested to verify they have the competence to deposit sound welds within the essential variable scope of each qualification. This shows a scenario of 3 PQRs qualifying a total of 6 WPSs needed for production welding. In this new scenario, a TIG root and stick fill requirement does not necessarily mean a new PQR is required. If existing PQRs for each process cover the essential variables, then the 2 PQRs can be listed on the new multi-process WPS. Switching now to CSA structural welding requirements, it is important to understand differing terminology now means the WPS is not the recipe to be used for production welding, but instead a general multi-page document. In my humble opinion, although you must have these in a W47.1 certified company, these documents do not serve any useful function and can be safely stored out of sight in a filing cabinet. Essentially, W47.1 will require a new WPS for each process and base metal type. So a separate WPS would be needed for flux rolled arc welding of mild steel and the second one for flexor welding of stainless steel as an example. You must document all production welding requirements on a welding procedure data sheet. That's a WPDS for short. And that gets approved by the Welding Bureau with one of these next two methods. In this first scenario, our objective is to document a subarc welding procedure data sheet that meets the pre-qualification requirements of CSA W59. In developing the optimum parameters in welding the S2-1 joint, you will also need to ensure other pre-qualification requirements are met. For example, do not exceed layer thickness or bead width limits defined in Clause 10 of W59. The next step is to document your welding recipe, or WPDS, in a format that provides explicit and simple instructions to the welder. Each WPDS must be approved by the engineer in a Division 1 or 2 company, complete with their PN stamp, or instead signed by the Division 3 welding supervisor. After review by the Canadian Welding Bureau, the WPDS, in compliance with pre-qualified requirements, will be returned with approval and ready for use in production welding. In this next scenario, we will look at the steps to qualification if the WPDS is not pre-qualified. In experimenting for a joint with a reduced gap and bevel angle, you should verify complete joint penetration by either NDE or cut and etch testing. After documenting the WPDS, you will then coordinate the welding of the P-core test assembly with the Canadian Welding Bureau, followed by the required mechanical testing. After the approval process, all documentation is submitted for approval and then returned for use in production welding. One engineer I worked with told me to make all WPDSs pre-qualified so we would save the time and expense of qualification testing. That's not always the right decision, however, as we will see in the two examples we just reviewed. This spreadsheet has the cost data for the two procedures, with the only change being the cross-sectional area for the two joint designs. Once we input a length value, that will complete the weld weight calculation to arrive at a cost per procedure. Starting with an arbitrary length of 75 feet, we see that our overall costs are higher with the non-pre-qualified joint due to the $2,000 investment in qualifying that procedure. Increasing to 90 feet of welding, we see we're close to breaking even. With 2 more feet of added for a total of 92, we have now paid off our investment in procedure qualification, with welding beyond that resulting in higher savings. If we increase the welding length to 200 feet, as shown here, we see a $2.4 thousand savings with the reduced weld cross-section. So the moral of this story is to do your number crunching homework before the decision to forego non-pre-qualified procedures. And by the way, during welding labs, I have seen more than one group of students demonstrate weld soundness on this application or even less cross-section joint designs used. Switching back to ASME weld procedures, this is the downloadable WPS template available from the ASME website. It might make WPS creation an easier option for the creator, but I think it fails miserably at its actual function, which is to provide instructions to the welder on how to make the weld. With this single WPS template a catch-all for all welding process, the highlighting in yellow shows areas that are non-relevant or not needed for this flux core arc welding application. That's a lot of wasted space and confusing information that's not needed. A very poor example of providing clear, explicit instructions. There's nothing in ASME Section 9 that prevents you from creating your own WPSs, provided all the relevant variables are included. If there's data not needed, eliminate it from the WPS, and it can be easily confined to a single page with lots of room for preparation and pass sequence sketches. If you are really ambitious, it's possible to create forms using common word processing software that limits data input to only relevant cells with label data locked out to prevent unwanted changes. It also makes WPS creation faster with the option of adding context-specific help or drop-down boxes for selecting versus typing. In regards to some of these weld procedure issues, I strongly encourage you to read the 2 articles linked in Section 8 of our eConestoga D2L site. Another reminder that in not having lab access while we isolate, the WPDS assignment is not required and will not be factored into your final mark. Questions, comments, or weld procedure problems? You know how to get a hold of me.